Welcome everyone. This presentation will be, thank you, yeah. This presentation will be about Slither, but mostly some advanced parts of Slither, or rather some typically unknown aspects of Slither. Usually people are aware of the basic running Slither to statically analyze the code and basically run some detectors on the code. But there's also some interesting plugins, some printers. I will show those, but also I'll briefly go through what Slither is, so don't worry about that. So what is Slither? It is a static analysis framework, a trail of bits. Static analysis meaning that it will essentially go through the bytecode and analyze the bytecode of a smart contract, meaning that it does not have like knowledge of past transactions of the smart contract or the storage values or something like that. Rather, it's just looking at bytecode. It aims at detecting vulnerabilities in Solidity code, so just Solidity, even though it runs on top of bytecode. Basically, only in Solidity bytecode, essentially, or Solidity compiled. It will fetch a smart contract in Solidity. It will run the solc to compile them, and as we'll later see, it will also convert it to an intermediate representation where basically the trail of bits teams or the Slither code will work on top of it. So it also has some printers which very nicely report some information of the smart contracts or of an entire repo as well. Basically some summarizations. I think they are very useful. So I will show a bunch. I'm not going to show everything. It has seamless integration with Hardhat and Foundry, which is pretty nice. Not always was this the case, but as of now, for example, if you have a Foundry repo, all you need is really to install Slither, and then you run it, and it will immediately understand that it is inside a Foundry repo and, well, basically act accordingly, which is pretty cool. It wasn't always like this, and often the configuration part was a bit of a pain, but now it's really good. It's written in Python. There's a detector API available, meaning that you can build your own detectors leveraging the Slither internal representation, which is also pretty interesting. We're not going to do that, but yeah, just so you know. So how does it work under the hood? I'll show you just some snippets of code of Slither. It's Python, so even if you don't understand Python, I think it's readable enough. So I divided it into 3 steps. First step is contract parsing. So essentially there's a parser which will use something called the critic compile. Critic is the trail of bits team. And they have a specific repo called the critic compile, which basically will compile the Solidity code using a Python library. And it has this solc class, which is a wrapper around the solc compiler. I guess it will let you have some useful objects and artifacts available in your Python code, basically. So that's the first level of it, contract parsing. Then you convert, or Slither converts this parsed contract into Slith IR, their internal representation. They do this through these analyze contracts, where the first step of analyze contracts is basically converting to Slith IR. as you can see, there's this convert to SlitIR, which is here, and then this generate SlitIR and also convert expressions. Here it is. So it generates basically SlitIR node by node, in the sense that there are different nodes, or when we are building a tree with the bytecode, we can see it as different nodes, like, or maybe you would see it as code scopes, for example, block scopes, like, for example, an if statement block or for loop, those sort of things. So you have it like here, convert extraction. So it basically goes and checks, is it an if statement, a loop, and it basically stores every expression of the code into this internal representation. Okay. The third step is analysis of this internal representation. As you can see here, basically after the generation, you have the analyze read and writes and analyze calls. The analyze read and write is really essentially just checking every single variable writing or reading, whether be it on storage or just memory writes. And you have the analyze calls, where you check all the calls. So just on top of this, you can imagine some detectors being built. For example, if you just want to build like a reentrancy detector, you'll have to see at least a pattern where there's some writes being done to the storage and then some external calls being made, right? Or maybe external calls based on some storage reading, and only after the external call is the variable updated in storage, right? Yeah, basically this is the point of it. So let's dive into the Slither. I just called it core just to separate it from the printers and the tools that I'll show. So this is let's say the vanilla Slither. You can find typically such a file in typical DeFi code bases, like a slither.config.json. It might have a bunch of stuff, does not need to exist essentially, but you can, for example, specifically or help the Slither program to understand some remappings. It actually understands the Foundry remapping, so that's good. Can filter some contracts. For example, you don't want the Slither tool to run against the tests files or the dependencies or the scripts or any other such thing. You can also ignore certain specific detectors. Yeah, so you can do a bunch of stuff here. And then, for example, this is just running the Slither tool against one of the repos from Immunify, which is just a single contract, which is the splitter contract. It is part of the Immunify's bug bounty, and you just essentially it is a Foundry repo, so you just run slither dot, and it will automatically understand it is Foundry, so it will run Forge, as you can see, to build everything, and then it will run the Slither tool, and the typical output is something like this, right? So you'll have some detectors with different colors as well, depending on essentially the severity of those detections. We can check these detections. For example, the first one. So these are separated detectors that Slither runs, all of them, against your code. Here we have the detector sends ETH to arbitrary user. Okay, so any place it finds some ETH being sent to some input address, for example, it will flag that. Okay, and here a less priority, less severity finding. it's just the detector of finding low-level calls. So we are using here a low-level. And as you can see, these are not per se vulnerabilities, right? These are just sort of red flags or potential red flags. So because Slither is just a generalized detection tool, so it finds some patterns that might be exploitable, some patterns that might lead to a vulnerability. Okay, but it does not mean that these are vulnerabilities. So yeah, and here specifically, these two are not vulnerabilities. We can indeed send ether to an arbitrary destination, to an arbitrary user, if that's what we really want. And low-level calls, anybody can do low-level calls. That's not an issue. Yes, we need to like pay special attention, but it's not a vulnerability to use low-level calls. So there's also a command where you just add this flag, this triage mode flag, okay? And the way it works is that it will show those previous detectors, but it will show them one at a time, or the results of each of those detectors. So here, for example, it will show the results of the detector of sending ETH to arbitrary users, and it will ask me whether or not, essentially whether or not this is worth pointing out, and if I want to just, in essence, acknowledge this finding. Okay, so as you can see, it asks me which results here, which is just one, which results I want to hide for the next runs. Okay, so this is essentially an acknowledgement. And so I typed 0, meaning no, or maybe all. It is the same thing, meaning that I don't want this number 0 finding to be shown again. And then the other detector results will appear, and I will put 0 as well. So the next time I run Slither dot, as you can see, there are no findings because the previous ones were already acknowledged. Okay, so it is in this case it's just one single smart contract, but when you have a repo with a lot of smart contracts, if a ton of the findings that Slither outputs to you were already acknowledged like so many times and you just ignore them, it is a bit of a pain to just have it verbose like that. So it's good to be hiding all the findings that are not actual vulnerabilities. That way, the next time you do some extra code and you run it again, you'll only see the actual vulnerabilities. Okay. And when we do this, when we run the triage mode, we get this file, this slither.db.json, which will basically store a representation of those acknowledgements of those findings. Okay, basically that's it. Another way to disable these findings, or yeah, to basically acknowledge as well, is to put the Slither disable next line comments. It might make your code too verbose. Might be, if you end up putting a ton of these comments all over your code, it makes it less readable. But sometimes you can use it. For example, here I am disabling the detectors arbitrary and ETH and low-level calls. I could also disable it globally, but maybe I just want to disable it here, and next time somebody on my team codes a low-level call, I want the detector to show that, basically. Okay. So yeah, here this is the same way. This is the same typical structure as you would do, for example, for disabling some linters. Slither dash disable dash next line. Okay, so that was just the typical Slither, vanilla Slither. Okay, it has a ton of detectors which I I didn't show, like the reentrancy ones and ERC compliance ones, a bunch. And you can just run Slither and it will run all those detectors. So the Slither printers are basically some useful additions of the normal Slither that actually lets you analyze a code base really quickly, at least some key aspects of it. Okay, for example, this Slither dot and then dash 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 print human summary. It will essentially print out this very neat summary where it tells you the number of lines, number of contracts, all the issues in Slither, sorted out by severity. And here we don't have any issue because we acknowledge the issues on the splitter contract. All the ERCs that are basically being manipulated or implemented. And then we have some features essentially. So it receives, for example, the contract splitter receives ETH, sends ETH, and has some interaction with tokens. Okay, if the contracts end up being more complex, it will show all the features here, and it is very interesting to just see a general picture of it. We have also the printer CFG, like control flow graph, where you see basically a graph with the expressions in Solidity and also the internal representation of Slither. I know that this is very small. Don't need to like read it, but the point is that it provides you a state machine-like representation of the flow of a contract, okay, or of a given function. So essentially, it is very interesting to see, for example, loops and if statements, as this is the beginning of a loop, by the way, which will begin here. And if there was some break, we see that there's no break on a loop, on the loop. This just comes back here until it eventually breaks when the statement, when the expression here is false, and it will go to the other path. Okay, but if there were some statement that could break the loop, it would appear here. So it's a very visual representation. I think it's pretty useful as well. We have the function ID printer. This is where you pass a specific contract to Slither. By the way, here I'm specifically passing Slither instead of dot. I'm putting source slash Slither.sol. And when I do this, Slither will no longer understand Foundry remappings. And hence why I just put here like a note where I had to add Sol C remaps, where I would say, because Splitter is using Open Zeppelin contracts, I had to put here the mapping of it. Okay, so that Slither can understand it. Anyways, you can see all the functions, including the inherited functions like owner, renounce ownership. These are all from the ownable contract. And you see all the functions, including the public variable functions, the getters, with their IDs, with their selectors, which is pretty interesting. It is a nice way to have them all very quickly. Another useful one, just for a single contract, is the constructor calls printer, which tells you the sequence of constructor calls. So the splitter contract has its own constructor, and then it inherits two contracts from Open Zeppelin, the ownable and the reentrancy guard. And as you can see, this tells you what are the constructors that will be run first, okay? In case you have any doubts, okay, here it is. The first is the ownable constructor, then the reentrancy one, and then the splitter one, okay? Sorry. Also, very similar to this, you have the modifiers, which is again, these are all interesting ways of seeing like the high level information of a contract. And here you can see all the modifiers on each function of a specific contract. this would be useful, for example, to spot any function that should be access restricted, but it is not really. So you can see the ones that are using the only owner modifier, for example, and you could easily spot a function that should have it, but it doesn't have it. Okay, it is a nice way to see. This is I'm showing this as well just for reference, but to me it's a bit verbose, very difficult to understand. But this prints out the require statements on each function, all the require statements on each function, which again, it's also pretty useful. It also adds the require statements of the modifier on that function. But if you have a ton of require statements, this becomes too verbose and no longer useful. I think this is the last one, the last printer. The variable order printer will essentially show the storage of a smart contract, the storage layout, not the values, and also with the offset on a slot. So if you might be aware or not that Solidity, once it compiles, will do slot packing, meaning that each slot on the storage has a size of 32 bytes, and some variables might together fit into a single slot. Okay, so the original splitter has these 4 variables, which each of them occupies a single slot. Okay, but I added here some extra variables, these X, A, B, C, D, E. And as you can see, some of them can be slot packed, basically. So there's the X, which goes to a new slot, and this is uint 256, which is 32 bytes, so it fits the entire slot. Then you have the uint 8 in slot number 5, which occupies 1 byte. And because the next one is uint 16, which is 2 bytes, it still fits into the former slot. So as you can see, it's still on slot 5, but with an offset, right? This occupies the first byte, then this starts at this occupies the byte number 0, and this starts at byte number 1, okay? And then the variable C still fits into this slot, and it will start at byte number 3 because the B variable occupied 2 bytes, okay? And so on. The address occupied 20 bytes, so the next one starts at 23. And then finally, the splitter.e variable cannot fit into the former slot, so it goes to a new one. Okay, so basically, as you can see, these variables were all fit into a single slot. It is interesting to see that this shows the layout, including the storage variables of the inherited contracts. So you can have a very nice way of looking at the entire layout of the contract. Okay, maybe particularly useful, for example, if you are hunting on upgradable contracts and you are looking for any potential storage collision. Okay, those were printers. Slither, besides having these printers, has these things which I called it tools. You can call it like modules as well or something. But they are some extra functionality built on top of Slither, which can maybe use some extra things. For example, it could use some data from the blockchain, for example, like the storage values, as we will see. And the first one is this Slither Check ERC, which is a module that allows you to check if a certain contract follows the proper standard. Okay, so when I run against the splitter contract, it will by default check, because I didn't say anything else, it will by default check if this contract is an ERC20 or if it follows the ERC20 standard. It doesn't, because this is not a token. So a lot of things here, or everything missing. But I ran against the ERC20.sol of OpenZeppelin, and as you can see, you have all these check marks, basically things to check whether or not you are ERC compliant, right? Yes, okay, total supply is present, is a view function, events are emitted, right? These sort of things, and even has these extra beyond the ERC20 standard, but they are like good practices, which is to have this increased allowance function to protect against the approval race condition. As you can see, the splitter is not protected for the ERC20 approval race condition. Here, this ERC20 is because of the increased allowance. Anyways, you can do this on a number of contracts and not just the ERC20 standard. Okay, you can run it against some other EIPs as well. Then you have Slither Find paths. This is extremely useful when you want to basically see how a given internal function, for example, or the amount of times this internal function ends up being called. Okay, so the module will do a path where it starts at some external function, eventually reaching the target that you selected. Okay, so here, as you can see, we are running this against the ERC20.sol, and for the internal function underscore transfer. And this target function will be run by two functions, the transfer and the transfer from. And here are the paths, which are very, very easy paths, but could be much more complex. And this way you will have all possible paths to reach a specific target function. It's pretty cool. Finally, you have this Slither read storage. This module essentially will use, might use Etherscan, might use also an RPC endpoint, and you can run against a specific contract on the blockchain. So basically the point here is to also provide, you can also provide the layout as you see here, but we'll see that in a bit. But most importantly, you can query specific slot values, okay? And those slot values also, it can be particularly useful, for example, for mappings or for something else like that, right? Where you have nested things like arrays in storage or something like that. But here I'm specifically querying the value of variable fee recipient. Okay, so you can name the variable. You don't need to say, oh, I want slot number X. So you name the variable, even if it's private, it will show you the type of the variable, the slot where that variable is stored, and it will tell you also the value, which is here, this address. I did the same here for the fee. As you can see, it's a U in 256. And if you want all values of the variables of the smart contract, so not accounting for mapping values, you can do it like this, passing the flag table, where it will show you the various variables with the slots, the sizes, and the values on. Okay, so this is a very easy, quick way to get the entire storage layout with the values that the contract has on chain. I think it is particularly useful. Okay, that was it. Some resources that so Pepin has been linking. You can check out the Slither GitHub by the Critic team, which is the Trail of Bits team. It is in Python, so it's more readable than some other code bases. For example, Echidna. The Echidna code base is written in Haskell, which is much more tough to read. So this one is pretty understandable, I would say. Also, the Critic compiler, which is the Python compiler or the wrapper of that Slither uses. There's an article which is basically maybe the only documentation on one of the modules of Slither, the read storage module that I showed in the end. And also, just as a reference, recently the Pessimistic team released some detectors that they built using the detector API of Slither. They called it Slitherin, which is pretty cool. And it is an interesting, a good example of a way to build detectors leveraging the API of Slither. Basically, you leverage the internal representation of Slither, which is pretty cool. So you can build stuff that goes much more beyond the general detectors of Slither. All right, thank you very much, Dan. Be sure to check out our new bug bounties channel and the BBP updates channel to be updated for the scope of any of the bug bounties that we currently have on Immunify. And that's it. Thank you very much.